All right, here's the last video for section 11.1. We're going to work on some applications. Here are some hints for solving applications for systems of equations. Number one, when you're reading the problem, make sure you highlight the important information. Number two, make sure you define your variables and include units. Hint, the variables usually are the answer to the question being asked. Number three, make sure you write two equations because you have two unknowns. Usually each sentence will come up with an equation. Not always, sometimes they smush them all together into one sentence. But each sentence or phrase is usually an equation. Use one of your methods for solving, graphing, elimination, substitution, and always be sure to check your solutions. All right, so let's give this a try with a problem. Problem number one. You are running a cookie and lemonade stand in front of your residence. Each cookie costs $1.50 and each cup of lemonade costs 50 cents. At the end of the day, you have made a total of $78.50. You sold a total of 87 cookies and cups of lemonade combined. How many of each type did you sell? All right, so the first step, we've highlighted things as we read along, all the important numbers. So now we're going to go on to defining our variables. Well, the question asks me, how many of each type did you sell? So I want to define my variables to be the answer to that question. So I'm going to make C be equal to the number of cookies I sold. And I'm going to make L be the number of cups of lemonade. And that way, when I know the answers to what the values C and L are, I can answer the question, how many of each type did I sell? All right, we need to come up with two equations because we have two unknowns. The first equation, I think, can come from right here where it says you sold a total of 87 cookies and cups of lemonade combined. So that tells me that C plus L is 87, right? The other information is all from this business right here. Let's put it in green. Each cookie is $1.50. Each cup of lemonade is 50 cents. At the end of the day, I made $78.50. So how much money would I have made from cookies? Well, if I sold 10 cookies, I'd make $1.50 times 10, which is $15, right? So what did I do? Well, I took the number of cookies and I multiplied it by $1.50. So the amount I make from cookies is going to be 1.50 times C. That's how much money I get from cookies. I'm going to add that to the amount of money I get from lemonade. Well, lemonade is 50 cents a cup. If I sold 10 cups of lemonade, I get $5, right? So I'm going to take my 50 cents, 0.50, I'm going to multiply it by the number of cups of lemonade that I sold. This is going to be my dollars that I got from lemonade. And that makes a total amount of $78.50. And there are my two equations. I can use either substitution or elimination or graphing to solve these. I think I'm going to go ahead and use elimination. So I'm going to look at these equations and I'm going to multiply the first one by negative 1.5, I think. So negative 1.50 times the first equation, and that would give me negative 1.50C plus negative 1.50L equals whatever 87 is times negative 1.5. Negative 130.5. My first equation stayed the same. So my second equation stayed the same. Add these guys together. The C's drop out. There's a C there. The C variables drop out. And I get negative 1 times L equals 130.5 negative plus 78.50. 52, negative 52. Divide each side by negative 1, and I get L equals 52. So that means I sold 52 cups of lemonade. Substituting this back in, I know the number of cookies plus the number of cups of lemonade is equal to 87. Subtract 52 from each side. And I get C equals to 35. So that means I sold 35 cookies. 35 cookies and 52 cups of lemonade. right, let's double check our answers here. First, let's check C plus L equals 87. Does 52 plus 35 equal 87? Yes. Then let's check our other one. Is 1.5 times 32 plus 0.5 times 52, what does that equal? 1.5 times 32 plus 0.5 times 52 is 74. What? Did I type wrong? Let me try that again. I don't think I did it wrong. 1.5 times 35. That would be helpful. Yeah, that's supposed to be a 35, guys. Plus 0.5 times 52 equals 7850. Check. It's always good to check your answers. All right, that one went pretty well. Let's try another one. You are You are shopping for flowers. 6 petunias and 4 marigolds cost $13.50. 6 petunias, 4 marigolds, total cost $13.50. 4 petunias and 8 marigolds cost $13. What is the cost per flower of each type of flower? So again, we want to set up our variables so that they answer our question. The question is, what is the cost per flower for each type of flower? So I'm going to make P be equal to the cost of a petunia. If I did marigolds, could you imagine? It'd be totally confusing. Cost of a petunia. And I'm going to make M be the cost of a marigold. And that way, when I know those values, I will be able to know what is the cost per flower. Okay, well, the first sentence tells me 6 petunias and 4 marigolds cost $13.50. So if I take 6, the number of marigolds, times P, the cost of the marigold, that'll give me the total cost from the marigolds, plus 4M is equal to $13.50. And if I do 4 petunias, 4 times the cost of a petunia, plus 8 times the cost of the marigold, I get $13. There's my 2 equations. We can solve these using whatever method. I am very partial to elimination. I just think it goes a lot faster. So I'm going to use elimination, and I can see right off the bat, if I multiply my first equation by -2, then I will get that guy to drop out. So let's just actually do that right here. -12p plus -8m equals 13.5 times 2, which I think is 27, but I'd hate to mess it up. Yeah, equals -27, negative, add down, -8p equals -27 plus 13, which is -14. Divide each side by -8, and you get p equals 1.75. So the cost of the petunias are $1.75. To figure out the cost of the marigolds, we just need to plug that into one of our equations. So 6 times 1.75 plus 4m equals 13.50. 1.75 times 6 is 10.5. Minus 10.5 from each side. 4m equals 3. Divide by 4. M equals 0.75. And it's fine to use a decimal. This is dollars anyway. So the price of a petunia is $1.75, and the price of a marigold is 75 cents. All right, we should check our answers. I'm going to let you guys check your answers on your own. I think I have one more to do. Yes, I do. So these are the mixing problems. They're a little bit trickier than the other ones, but we're going to do it, and we're going to figure it out. So if we have a scientist, and he mixed 10% saline solution with 60% saline solution to get 25 gallons of a 40% saline solution, how many gallons of the 10% and the 60% solutions were mixed? There's so many numbers in here, it does get a little confusing. We're just going to go slow and work our way through it. So the first thing we need to do is we know he's mixing a 10% saline solution with a 60% saline solution. And in the end, he's ending up with a 40% saline solution. So he's taking a solution that isn't very much saline with one that has a lot of saline to get something kind of in the middle. All right. So the question being asked is how many gallons of the 10% and the 60% were mixed? So let's make those our variables. I'm going to use X for the amount of 10% used. And I'm going to use Y to be the amount of the 60% used. All right. So let's see if we can come up with a couple of equations. We know that they mixed some of this 10% and some of the 60%, and they ended up with 25 gallons. And we're going to have this units be gallons. So one sentence that we know, one equation that we can get from a sentence is that the amount of the 10% plus the amount of the 60% makes a total of 25 gallons. Okay. What's another bit that we know? Well, we know we end up with 40% saline solution. So what we need to do is we need to think about how much saline is going into each part. Well, for our amount in X, if we had 100 gallons, 10% of it would be saline. So of that 100 gallons, 10 gallons would be saline. How did I get that? Well, I took 10% of 100, right? If I have 100 gallons of solution, 10% is saline. I take 10% of 100, and that's how much saline I have. So this second equation is going to be how much total saline is going to be in this mixture. So I'm going to take 0.10 times X. That's the amount of saline from the first mixture, from the 10% solution. Likewise, if I had 100 gallons of the 60% solution, 60 gallons would be saline because I took 60% of my amount, and that's the saline from the 16% solution, a 60% solution. So what does that equal to? Well, and my final solution is 40% saline. So I have my 40%, and people are really tempted to stop here, but our units aren't going to be the same, okay? On my first equation, let me get to a different color. On this one, I have 0.10 times an amount, 10% of a gallon. So that's going to give me gallons. Here I have 0.60 times a gallon. So that's going to give me gallons. If I stopped here, I just have 40%. That's not going to be units, gallons. Well, it's going to be 40% of the 25 gallons that I have. So you have to remember to put that in there as well. All right, so there are my two equations. Let's go ahead and figure out what 40% of 25 is. It's 10. So my two equations are X plus Y equals 25 and 0.10X plus 0.60Y equals 10. I'll use substitution for this one because I've done elimination on the previous two. I'm going to solve the first equation for X. X equals 25 minus Y. Plug that into the second equation. 0.10, 25 minus Y plus 0.60Y equals 10. Distribute. 0.10 of 25 is 2.5. Minus 0.10Y plus 0.60Y equals 10. These are like terms. 2.5, 0.1, minus 0.1 plus 0.6 is 0.5. Subtract 2.5 from each side. 0.50Y equals 7.5. Divide that in half. Divide that by a half, sorry. I said that sloppy. And I get 15. 15 gallons of Y. What was Y? I had to do so much writing I can't even remember. Well, let's go back and figure out in a second. What am I highlighting? 15 is Y. I bring that back up here. X equals 25 minus Y, which is 15, so X equals 10. So how much of each solution was mixed? 10 gallons of the 10% solution. And 15 gallons of the 60% solution. Let's double check our work. What was my two equations? Did those add up to 25? Yeah, they definitely add up to 25. And let's check the second one. Is 0.10 of 10 plus 0.6 of 15 equal to 10? We'll find out. 0.1 times 10 plus 0.6 times 15 equals 10. Sure enough, we did that one correctly. All right, that's it for section 11.1.